Okay, we're going to be using the product rule for logarithms and expanding logarithms out. So what the product rule says is if we have two things that are multiplied together on the inside of a logarithm, we're allowed to split these apart and put each factor inside of its own logarithm and separate these by addition signs. This is assuming that our base is positive, which it always has to be for a logarithm. So as we take a look at this, we're going to walk through the steps on these. I'm going to try to expand each one of these, but we're also going to take it first one step at a time. Then we'll talk about a little bit of a shortcut to speed this up a little bit. So looking at this first one, first thing you may notice is we definitely have a multiplication symbol in between here, between the 7x and the 2y. So one way to get the going on this is go ahead and say, well, this is going to be log base b of 7x plus log base b of 2y. All right. We can expand this further, however, kind of visualizing that this is 7 multiplied by x. So we can split this apart one more time for this first logarithm and say log base b of 7 plus log base b of x. Plus, we can kind of do the same thing over here. We have 2 multiplied by y, so we can split those apart, giving each one their own log. And we're going to be separating these by an addition sign again. All right, so that's as far as we can expand this out, as we have prime numbers on the inside here. We aren't going to be able to factor the 2 or the 7 any further. Neither will we be able to split up the x and the y. So what you may have noticed on that last one is whenever we had a multiplication in between two things, they each eventually got their own log. So one way to speed this up is simply jumping straight to, like, the 3 is multiplied by everything else, it's going to get its own log. The a, the same idea, it's multiplied by everything else, it gets its own log, b, 5, and c. So when we split this apart, eventually we can get natural log of 3 plus natural log of a plus natural log of b plus natural log of 5 plus natural log of c. And I knew these were all going to get addition signs. One reason being that everything's multiplied together, but everything's in the numerator. As we get going on these, as we learn the other rules, we want to be careful about if it came from the numerator, if this factor came from the numerator, it's going to be positive out in front of that logarithm that's attached to it. All right, let's look at log base b of 8k. So I'm moving in the right direction on this. You may say to yourself, well, we have log base b of 8 plus log base b of k. That's the obvious, multiplication going on in between these two. However, we could split this part a little bit further if we kind of think about how would I factor 8. It's not a prime number, so we can factor it and split it apart maybe 4 times 2 instead of 8. That's going to split apart further, and we can say log base b of 4 plus log base b of 2 plus log base b of k. But then we could go one step further, right? 4 is not a prime number. You could split this apart as 2 times 2. Let me write that in a different color. So 2 times 2. And because these are connected with multiplication, we can split this apart one more time. Log base b of 2 plus another log base b of 2. That was splitting up this first logarithm. Now we can bring down this next log base b of 2 plus log base b of k. Comes down as well, bringing this down. Now the last thing you may notice is we have 3 of the exact same thing, right? We have log base b of 2 plus another copy plus another copy. One way to more efficiently write this is we have 3 copies of log base b of 2 plus log base b of k. Simply kind of combining these, what you kind of think of as like terms, 3 copies of the same thing together. That's where this 3 in the front came from. All right, so from that you may be saying, well, maybe there's a more efficient way to do this. Okay, how I like to approach these is factor any composite number from the very beginning. Then you can work on just jumping to splitting them apart, as we'll see in this last example. So we have log base 3 of 30 times x times this quantity, 3x plus 4. So that 30 out in front is not a prime number. So what I may do off to the side is just try to factor that completely. So I'm going to make a factor tree really quickly and kind of say to myself, okay, we have 30. I know I can split that up as what, 5 times 6 or 2 times 15 or 3 times 10. Just pick whichever way you see first. 5 is a prime number, so we'll stop with this branch of the factor tree, but 6 is not. So we can continue on. This will factor further as 2 times 3. Then what happens is if we multiplied all of the ends of these branches together, it means the same thing as the 30. So we can say 2 times 3 times 5 or 5 times 2 times 3, whichever order you want, can replace our 30. So with that, if we kind of visualize that as the factored version of 30, everything's now multiplied together. We have 2 times 3 times 5 times x times this big set of parentheses. Let's just jump to splitting everything apart. Basically, each factor gets its own log base 3. So log base 3 of 2 plus log base 3 of 3 plus log base 3 of 5 plus log base 3 of x plus log base 3 of that last set of parentheses, 3x plus 4. All right, so it's expanded as much as possible. We're not going to be able to split this up because we can't factor anything else, and we can only split them apart if we can get factors, right, being multiplied by the rest of the everything inside of the logarithm. This won't factor any further, but there is one more simplifying down we can do. And this is kind of a special case that we have log base 3, and then we have 3 on the inside. So by the inverse function property, we have an exponential function inside of a logarithmic function. Whenever these bases line up, you're going to get nice canceling out, and we're just going to be left with the exponent. So the best final answer I think we can get for this is log base 3 of 2 plus 1 for that log base 3 of 3 plus log base 3 of 5 plus log base 3 of x plus log base 3 of 3x plus 4. And there we have it, as expanded out and simplified down as possible. So I hope this helps out as we're trying to figure out how to expand logarithms using the product rule. Good luck.